Okay, I gotta say, I'm very excited to have Nick in the channel. So, Nick is the CEO of Celestia. And yeah, Nick, welcome to the channel. I'm very excited to talk about you and learn about the disruption that Celestia is bringing to the whole ecosystem. Welcome, Nick.
Thank you, Alex. Excited to share what we're building at Celestia and this new technology that we call modular blockchains.
Awesome. So, Nick, first things first. And we will also like to know a little bit about you. So what's your background? What's your personal story in crypto? How this whole life in blockchain and crypto started for you?
Well, I actually come from an engineering background. I studied electrical engineering at Stanford, and actually was more on the AI side at the beginning of my career, but quickly realized that AI was kind of leading towards a path where the world's power would be more and more concentrated, and that people really didn't have a lot of autonomy over their digital lives and their data and everything else. And then so I realized that wasn't really the world that I wanted to create. And I discovered crypto and realized that it was sort of more aligned with my values. It gave people more control and autonomy. It decentralized power and sort of leveled the playing field. And so very quickly I fell down the rabbit hole and got very interested in, what blockchain as a technology, what kind of impact it could have on the world. I got more and more fascinated with it. And then I realized basically that in order for that to happen, in order for that to become real, there was a really key problem to solve first. And that was actually making blockchains that were scalable enough to serve as this infrastructure to power all these applications and use cases. And so I really got fascinated with this idea of blockchain scalability. And so in 2018 is when I took the plunge full-time into crypto. I co-founded a project called Harmony, in which we were building the first proof-of-stake sharded blockchain. And it was a really great experience. It was my first time as a founder. I learned a ton, but I realized essentially that the approach with sharding was not actually the ideal approach. There were a lot of limitations, and that actually there's something better. And I read this paper in 2020, about 2.5 years into my journey at Harmony, called Lazy Ledger. And it outlined this idea of a totally different approach to building blockchains that I found fascinating, and that I realized solved a lot of these fundamental problems with blockchain infrastructure, not just scaling, but things like interoperability or even programmability, making blockchains more flexible and expressive. And so I immediately got hooked and ended up joining that project. And since then, we have rebranded ourselves from Lazy Ledger to Celestia. And now I've been on the team for about 1.5 years. And we're building, and we're soon going to deploy this blockchain. So it's kind of a dream come true for me.
Awesome. That's great to hear. Yeah, I saw that you are a co-founder of Harmony, which is also a pretty cool project. So I'm glad you found this whole path and you're excited for what you're doing. So that's great. Okay, Nick, I hear you're a man of analogies, and Celestia has many different concepts that could be or can be a little tricky for people. So why don't you help us to understand these 4 concepts that I think are very key: data availability, consensus, settlement, and execution?
Sure. So to give some background before we go too deep, one of the core ideas behind Celestia is that every blockchain, in order to run any kind of decentralized application, there are certain key functions that need to be fulfilled. And in a typical blockchain, what we call a monolithic blockchain, all those functions happen in the same time and are run by the same in the same network, essentially in the same protocol. And the core idea of Celestia is that actually, if you take a step back and you understand blockchains from fundamental first principles, you can separate out those functions and actually have them happen on different layers of the stack and as separate protocols. And when you do that, that's where that whole unlock is of modular blockchains I was talking about, where you get more scalability, more flexibility. You solve things like interoperability as well. And so those four things you just mentioned are the four key functions. And they are a little bit hard to understand at first because, we tend to think of blockchains as these black boxes. But I'll kind of maybe draw an analogy that hopefully people can relate to. So you could almost think of a blockchain as like a soccer game, right? Where you have players on the field that are, playing, and they're trying to score goals. They're like, passing the ball between each other, doing these things. But there's a set of rules that they're meant to follow. And then you have people in the audience who are watching and observing what's happening. And you can kind of think of like the players on the field as the validators who are kind of carrying out the actions of the blockchain, and the viewers as sort of like the users and the nodes in the network who are not producing blocks, but actually, observing and listening to the blockchain because they care about the outcome of that game. And so using this analogy, what's really important, right, about blockchains is that you know that the rules of the game that everyone has agreed to are not broken. Because, for example, if we're using Bitcoin as an example, one of the rules is that you can't just mint more Bitcoin out of thin air, right? If someone were able to do that, then that kind of ruins the whole point of the game, and it makes the whole Bitcoin network kind of useless, right? The whole point is that you have this scarce, like enforcement of scarcity. And sort of to analogize that to soccer, it would be as if like someone could go off sides, or, they could just like, run outside the boundaries of the soccer field and like, or just pick up the ball, right, and just like run it into the goal. Like then they're just playing a different game, and so you kind of lose the whole value of like, well, you were here to play soccer, not I don't know, rugby or something. Mm-hmm. So that's a really key point, is that like blockchains are all about everyone agrees to a certain set of rules when they engage in this game, and you can't break them. So now to sort of like to talk a bit more about these layers, right? You can think of the data availability layer as the idea that the game is recorded and anyone can watch it. So like the game is like everything that happens in the game has been recorded for anyone to watch if they want to. This becomes really important. For example, if there is someone who breaks the rules, I can actually rewind the tape and show someone, hey, I'll show you exactly where they broke the rules. So you like, in typical sports, you always have these instant replays, right? Where you can go back in time and see like, oh, what exactly happened? Okay, this is exactly what happened. So that's kind of what data availability is, kind of like recording. Awesome. The other layer would be consensus. And that's where you basically ensure that once the game is played, you can't go back in time and change what happened, which, obviously that would never happen in real life in terms of like a game context. But in blockchains, you're building blocks, and it's sort of like you're running this thing called consensus. And if the people who are running consensus, the miners, are malicious, they can actually go back and rewrite history. So the whole point of consensus is making it so that it's very expensive and difficult to rewrite history. Because obviously, we could play one game, and then all of a sudden I could just like start the game all over again because I didn't like the way that it turned out. Oh, you scored a goal. Okay, guess what? I'm starting the clock over, and that never happened. So that's where consensus comes in. Then you have execution, which is essentially where the rules actually get enforced. So it's not enough that we record the game and make sure that it doesn't actually happen, but we need some way of, when someone breaks the rules, people need to be aware of it. Like someone needs to call a foul and be like, hey, this rule was broken. We need to apply a penalty, or we need to, take away that point that we thought they scored, they actually didn't score it. So we're taking that away. So execution is basically where you enforce the rules of the game or the blockchain. And then lastly, the settlement piece is sort of like, if there is a dispute, you need to be able to have a way for everyone to agree on what the outcome of that dispute is. Like, let's say there was a flag called, right? You need to go back in time and review, watch that thing over again, and everyone needs to be able to say, we've all watched the replay and we all agree that on this dispute of like, the ruling could go either way, either in favor of the player or against the player, and everyone's going to agree on the same ruling essentially. So those are like the four major sort of layers of the blockchain stack, in terms of how you can think of them as like playing a game of soccer.
That's great. That's a great analogy. That definitely helped me out to understand, because I've been all over Celestia docs and on other videos trying to get it. Like it is very interesting. It's very hard to understand for someone that probably doesn't have a lot of background knowledge, but this analogy is great. Thank you for that. Okay, there's another concept that I think also I hear a lot in your interviews and others, other people from the team interviews, and is data availability sampling. Can you please explain us a little bit about that?
Yeah, so data availability sampling is one of the core technologies of Celestia, because Celestia itself is primarily a consensus and data availability layer. So of those 4 layers of the stack that we talked about, Celestia is designed to provide consensus, which is the history doesn't change, and the data availability part, which is the recording and replay sort of mechanism. And so data availability sampling is this technology where essentially you're able to know that a block, the data behind a block, like the video recording, is there without having to watch the whole thing. So imagine, I'm the guy with the camera and I'm recording the game, and I want to make sure that you want to know that I actually recorded the game. But the only way for you to know that there's no, typically the only way for you to know that there's, that you have recorded the whole game is for you to watch it yourself. But imagine if there's a way that you could just watch little moments of the game, and so it only takes you like 3 seconds, and then you can verify that like a whole hour of video was recorded. So that's one of the key technologies. And the reason that's important is that, as more and more games are being played, or as blockchains scale, right, and there's more and more transactions happening, more and more activity, that video gets longer and longer and longer, to the point where almost no individual person will be able to watch the whole thing. But it's not important that they actually watch it. It's just important that the video was recorded. And so if I can now verify that video is there without, watching it myself, that it saves a lot of time and makes the whole system way more scalable. I can also use a different analogy to sort of explain the mechanics of data availability sampling, the way that the technology works, is that it's kind of like flipping a coin, where let's say I had 2 types of coins, but I didn't tell you which one I gave you. I have a heads only coin. Every time you flip it, it always comes up heads. It's just 2 sides are heads. The other coin is heads and tails. Now but you're not able to see what it is, but I give it to you. How do you tell which coin it is? You would flip the coin over and over again. And with every time that it landed heads, you would become more and more confident that you had the heads only coin. So if you flip the coin, let's say 20 times, and it's always heads the whole time, you, at the end of that process, have a 99.9999 percentage confidence that I gave you the heads only coin. Now, if we map that to like block data and blockchains, the way that data availability sampling works is that you can either have 2 different kinds of blocks. You either have a block where all the data is available, or you have a block where some of the data is hidden. So this kind of like maps to the heads only coin versus the heads and tails coin. And I end up flipping the coins, which means I take little random samples of data from that block over and over again. And after I've done that enough times, let's say 20 times, I get a 99.99999% confidence that all the block data is available. So that's kind of, it basically that's a mechanism of how you're able to verify that all the data is there, that the whole recording of that video is there, without actually rewatching all of it. So like you could only end up downloading, 0.1% of the overall data, but have a 99% confidence that that data is completely available. So it's like it can be like 1,000 or 200x improvement in terms of like how much resources you need.
Yeah, that's another great analogy for that. Definitely, there's right there, scalability is right there with that data availability sampling. Okay, Nick, let's start diving a little bit deeper into Celestia, and please explain in a very simplified way what Celestia is and what it aims to do.
Yeah, so as I said, Celestia is a consensus and data availability layer, right? And so it kind of provides those two functions as a service to any applications that want to run on top of it, or any other protocols that want to plug into it. So you can think of Celestia as kind of like this, if we're using the soccer analogy, it's almost like a stadium as a service where you come to it and it provides like this infrastructure of camera recording, which is the data availability, and it makes sure that the game doesn't get sort of rewound, which is like the consensus piece. Like it ensures that like once the game is played, it doesn't change. And then anyone can come to that stadium, like Celestia Stadium, and play whatever game they want. And so the beauty of this is that, so again, the execution and the settlement part happen separately. And as I mentioned, the execution is the enforcement of the rules. And so one of the beauties of having this modular approach is that because execution is not defined by Celestia, Celestia doesn't choose what game you want to play. You can play soccer, or you can play tennis, or you can play badminton, or water polo. Literally any game that you want, you can play. You just have to define the rules. And so that's one of the beauties of this model, is that you get all this flexibility. It's very expressive. Whereas, for example, in contrast to a monolithic blockchain, because the execution is baked into the layer, the stadium itself, baked into the layer one, you can't just teach it to play a new game. It's a tennis stadium or it's a soccer stadium, and that's it. It can't. It's not as universal and expressive. So that's one of the really, really key things about Celestia. So you can, again, I guess Celestia is sort of like this very general purpose, very scalable infrastructure on which people can run their own blockchains in a decentralized and secure way.
That is great. Is it okay to say, like, I'm just making this up, is Celestia kind of a marketplace for blockchains where they can go and pick what they need, the modular stack, pick what they need to build their own solution? Will that be okay, or is it too far out?
Yeah, that's pretty much what we envision. We envision, as opposed to the monolithic approach to blockchains where everything is baked in and rigid and sort of fixed and defined by that one single protocol, we envision a stack that is very flexible and modular, where communities or developers or whoever, whatever they want to build, there's going to be a whole selection of different components that they can choose from, and they can stack them on top of each other to achieve the result that they want. So it is, in that sense, sort of like a marketplace where you're going to have a bunch of different options that you can choose from as a developer or as someone who wants to launch a blockchain. And Celestia is that base layer, that's sort of that base foundation component on which you stack everything else on top.
That's great. So are there restrictions for the apps developers or the blockchain developers in order to come and build on top of Celestia? Let's say Celestia is being built with the SDK of Cosmos or Cosmos SDK, and there is another app or another team that wants to build something on top of Celestia, but they want to build with Substrate for say something. Is that is that something that can't happen? Are there restrictions in there?
So there are no restrictions on the type of execution that you can do on Celestia. So, if you think about each one of those sort of like execution environments, Cosmos SDK or Substrate or EVM or WebAssembly, WASM, think of those as different games like soccer, tennis, basketball, etc. Like you can literally play any game on Celestia. You can load any execution environment on Celestia and it will work. However, the only thing that's different is that the way that the execution has to be run is in the form of a rollup, which is sort of has other sort of technical requirements. And a lot of these execution environments, for example, a lot of these teams on Ethereum are building EVM-based rollups. So there is some technology, like the development of rollups. Like I guess what I'm saying is that these execution environments need to be adapted so that they can run in a roll-up execution model. But as from the developer's perspective, once that execution environment has been made into a roll-up, then deploying contracts on that execution environment and everything else feels exactly the same. And I will say it's very encouraging to see all the progress recently towards making roll-up execution a reality, whether it's optimistic or zero-knowledge roll-ups.
Great. Okay, so this is getting very clear to me now, but I want to just make sure everything is getting clear for the people who's watching this video. And what does it mean for the apps developers, for blockchain developers, and for end users to have Celestia in their lives?
So I would say we're probably more of a developer-facing product. Well, yeah. In terms of like the direct users of Celestia will be the developers and like teams building blockchains, because they are going to literally plug into the Celestia data layer. They're going to be the ones, coming to the stadium and saying, hey, we're setting up our little field our soccer field to play our game here. And so they're going to be interfacing with us directly to make that happen, or the protocol directly to make that happen. However, I mean, users can still interact with Celestia directly if they want to, but to like make payments and things. But they're probably the users are going to be the ones interacting with that game and playing that game. However, the thing that will change for users in the future, and this is why I think Celestia is so impactful on a bigger scale, is that the infrastructure that Celestia will provide is going to be head and shoulders better than anything that any monolithic blockchain, because Celestia does not have the same issues of scalability. So I think it's kind of useful to talk about this. What that will mean for users is that they don't have to pay much. Like people have gotten used to blockchains, once they become successful like Ethereum, they get congested and you end up having to pay a lot in transaction fees. The cool thing about Celestia, and that is because a monolithic blockchain, always the size of the stadium is always fixed, essentially. You can't increase the size of the stadium to accommodate more people and more games. You're kind of stuck with the amount of capacity that you have. And so obviously, as that game becomes more popular, more people want to watch, more people want to play, you just end up getting overcrowded and everything gets priced out. In Celestia, the beauty of it is that the stadium can expand. The amount of space that it can hold actually expands with the number of people who are using it. So you don't end up with this problem where people get priced out, because as it becomes more and more popular, there's actually more and more room for more users. So that's a really beautiful thing that Celestia will enable is scalability from a user perspective.
Okay, I'm gonna save a question for later. First, just for the same reason, we want to make sure that this is thoroughly understood. What, in your opinion, what are the use cases that Celestia will unlock?
That's a really good question. I would say that, Celestia, the beauty of it is that where we are coming from with blockchains is that we're coming from a world where it's very expensive if you want to start a new game, because essentially what you have to do every time you want to start a new game, which is a new blockchain, is you have to build a whole new stadium from scratch, right? Which means that you have to basically bootstrap a whole network of validators or miners, and you have to secure that that chain with a valuable cryptocurrency, whether proof of stake or proof of work. And that's just a huge lift. Like, I mean, imagine constructing a stadium in real life is super complex and capital and resource intensive. It takes a lot of time, right? And so what that has resulted in is that it's just very expensive to experiment and to deploy new blockchains. It's really, and that's held back a lot of innovation around, experimenting with new kinds of execution environments, which is like new types of games that people might want to play, or even, just the idea that some people, rather than wanting to build on an existing blockchain like Ethereum, they want to actually have their own infrastructure and have control over their own stack. But the thing is that even if they wanted to do that, it's so expensive that it doesn't make sense. So instead, they decide to run on another blockchain. But basically, Celestia will drastically reduce the cost for building your own stadium, essentially, or for starting your own game. And I think that's going to lead to so much more innovation and also a whole bunch of new use cases, and give people a whole nother option that they didn't have before in terms of control over their blockchain technology stack, and the ability to just, our long-term goal is for people to be able to deploy their own blockchain as easily as they deploy their own smart contract. So like, we want it to be, literally a few lines of code, and you can have your own blockchain spin up on top of Celestia.
Well, I'm very excited for that, because definitely want to see more social applications in this industry and not just financial applications that we love, but we want to see this other element of what took internet to be what it is right now. And that's for sure going to allow that. Okay, before we go to a different set of questions, what can you tell us about Mustafa Al-Bassam? I hope I'm saying his name right. He's the CEO of Celestia.
Yeah, so Mustafa is the founder or the co-founder of Celestia, and he has an extremely interesting background. He started out as he actually was born and raised in Iraq, but he immigrated to the United Kingdom when he was a child, and he taught himself to program at a really early age. And being sort of like a very inquisitive person, he just got very expert at programming. And by the age of 12, he was already learning how to hack. He kind of taught himself that kind of things, and he got involved in online communities like Anonymous, and eventually there's like a hacker community, and he eventually co-founded this group called LulzSec. And he was really motivated by this idea that using a computer, even though he was just a kid, he could transcend sort of the power structures of the world, and he was able to hack into and put power in its place, and sort of like equalize and be an agent of like of good, I guess, for what he believed in. And so, for example, they hacked into various government agencies like U.S. Defense contractors, and exposed that they were doing some pretty nefarious things around the world. He hacked into various like multinational companies, corporations, and also exposed similar kinds of problems. And so basically, he ended up kind of transitioning away from that hacker sort of background. But he continued sort of pursuing this idea of like using technology as a way to equalize power, and to give to make people more autonomous, and to the world more, I would say, democratic and fair. And so that kind of naturally led him into blockchains. And so he's the person who after years of research during his PhD, came up with this idea of modular blockchains, and in fact coined the term modular blockchains. And has, I think that Celestia actually, the end promise of Celestia is to really provide this tool, this very powerful tool that anyone in the world can leverage to sort of like, empower themselves and their communities.
Wow, That gave me goosebumps for a second because I remember back in time in Colombia. I'm original from Colombia, and I do remember Anonymous, and I was like part of those DOS attacks. That kind of gave me goosebumps for a second. Okay, this is the question that I was saving for later, and I think this is gonna hurt a little bit because I've been watching other interviews from like members of the team, and they are very critical with ETH 2.0. What's your input in this? Is ETH 2.0 a bad version of Celestia?
Well, I think hopefully we're not giving that impression that we're super critical. I just think so. Actually, in terms of projects out there, Celestia is actually very, very closely aligned with Ethereum, both technologically and in terms of the social vision and the kind of impact we want to have. And so and in fact, Mustafa and even John, two of our co-founders, were deeply involved in the ETH research community up until maybe 2020 or so. And so we have a lot of, I would say, connection and overlap with the Ethereum community. In terms of ETH 2.0, essentially what's cool is that they've sort of increasingly over time sort of adopted this modular blockchain idea, and they're now aiming more and more towards a model that is similar to Celestia in terms of they're building a data availability layer on which people can deploy rollups. There are some architectural differences, but when you compare them, and those do have big impacts, but when you compare, let's say, Celestia to Ethereum versus like Solana, Celestia and Ethereum are very, very aligned in terms of where we see the space going, versus like Solana is kind of on its own direction, or a lot of these other layer ones, even Avalanche or what have you. So what I'm trying to say is that Ethereum and Celestia have way, way, way more in common than we have in differences, if that makes sense.
Yes, it does. Okay, so what was the main reason why you choose to build with the Cosmos SDK and not another solution out there?
This is great as a transition, or to also build off of this point with Ethereum, is that I would say that the next community that we have the strongest overlap with is the Cosmos community. And in fact, we kind of think of ourselves as sort of like this unifier of those two visions, in that like Ethereum envisions this world of like shared security for all these different applications, and Cosmos kind of envisions this future of sovereign blockchains that are independent, and the right for anyone to build their own blockchain from scratch. And Celestia is sort of like this unifier where we can have shared security, like a shared platform, a shared chain that enables anyone to deploy a sovereign blockchain. Whereas in Ethereum, you couldn't previously deploy a blockchain. You could only deploy a smart contract, which is sort of like a layer below, and it's not very scalable. So it's kind of like this happy medium and unification of those two very powerful visions for blockchains. Now, one of the other things about Cosmos, and one of the reasons that we chose to build using the Cosmos SDK and Tendermint, is that what Cosmos is they kind of they brought about this idea of modularity within not in the protocol stack, but within the software stack of blockchains. So what the difference is there is that, like, when you're building a blockchain protocol, obviously there's software that instantiates that protocol that the nodes run, right? Now that protocol could still be a monolithic protocol. It could do all the four functions within the same protocol, but at least you have the software itself is separated into, like, there's consensus software and then there's the execution software, for example. So in Cosmos, you have Tendermint and the Cosmos SDK. And it's just a very, very friendly, useful framework for us to build our blockchain. And you end up sharing a lot of common code with a bunch of different projects. So sort of like you're able to pool the resources of developing your blockchain on the software standpoint with other things. And it's so battle tested and useful. And then finally, I guess what I would say is that we are using IBC, as well as some of the sort of abstractions like ABCI within our own stack for rollups, because they're just very, very useful sort of like frameworks. Because the Cosmos community invested a lot of time into designing things in a very robust way, and so that's why those sort of our connection with the Cosmos ecosystem.
That's great. I'm now understanding why I'm so excited about Celestia, because for the longest time I loved Ethereum, and I still love Ethereum. It brought so much innovation in this whole ecosystem, and now I'm super in love with Cosmos. So you're saying that Celestia is a happy middle place. That makes me more excited about Celestia. So that's something that I just discovered why I was so excited about Celestia. Okay, so where are you guys currently standing? So like, how's the roadmap looking? So what are the challenges that you guys are facing? Like, how are you right now with the project?
So we recently, I think in June or late May, launched our first testnet, and it has all of the basic features in it: data availability sampling. It even has the first rollups, and people can send all kinds of different transactions and experiment with it. We even have something called the data availability API, which is this new type of API that essentially gives developers the ability to just plug directly into Celestia. It's sort of like a blockchain as a service API. Mm-hmm. And so we're really excited to launch that, and we're going to continue over, till the end of the year, releasing new tools that developers can play with on top of that testnet, like new kinds of execution environments, new kinds of roll-up tooling, and whatnot. And then longer term, so in Q1 of next year, we plan to run an incentivized testnet, which is similar to like Game of Stakes and Cosmos, or people have probably seen this in a lot of other networks, where we'll get a bunch of validators together and they'll sort of test run the whole network, and there'll be incentives, for people that participate. And then finally, if everything goes well and the protocol is robust and all the features are good, we plan to launch in Q2 of next year.
Awesome. So is this part, the API part, similar to what Pocket Network does?
So I think Pocket Network, if I understand, is more of like a decentralized RPC service. Mm-hmm. And RPC is an API in a sense where you are able to interact with the blockchain, but it's more about like, sending transactions or even like querying like the state of the blockchain. So I want to know, mm-hmm. What my account balance is, or what is this like the balances on this one smart contract, for example. You use an RPC for that. So This is slightly different in that this API is a way for you to outsource consensus and data availability. So you would call this API and you'd say, hey, basically, I have this block data that I want to post on Celestia, and so post it for me, essentially. So it's like, and then it will come back to you and say, hey, your data was posted, and here's like the proof, essentially. So it's more of like, imagine if you could, rather than having to create your own validator set and data availability service, you just plugged into, with a few lines of code, you plugged into something that did all that work for you, all the decentralization and technical, like the network that powers whatever blockchain application you want to run is just a few lines of code. That is what the data availability API is. Okay,
clear now. Okay, so to wrap up this conversation, what's your personal view? And if you can, what's the team's view on what is the application that's going to take blockchain, this whole industry, to the next level?
That is a really good question. I think the blockchain is very similar to the evolution of the internet itself. And if you rewind, to the 90s, and you watch some of the videos and interviews and people talking about the internet, first of all, there was just a lot of skepticism. People didn't think that the internet would be very revolutionary, and there's a famous quote by I think it's Paul Krugman, who said like the internet is just a fancy fax machine, basically, right? And so I also think that some of the applications that we're using blockchains for, like let's say payments or whatever, are just like email. Like we're just barely scratching the surface for the kinds of things that this technology platform is going to be useful for. Obviously, DeFi and NFTs have shown a lot of promise, but I still think, the range. I think blockchain is going to revolutionize almost every industry that it touches, and it's just going to be a matter of time until we see that. However, I don't have a crystal ball, so it's really hard. If I could predict, exactly what those use cases are going to be, then I would love to like help and build them, but it's so hard to know. Like no one could have predicted, something like Instagram would like take off, for example, in the 90s. It was just too far. And I think we're in a similar place where we need to build the infrastructure first, and that will enable developers to have the freedom and users to be able to like afford using these systems. And then we're going to have a whole nother wave of experimentation where people just try a bunch of things out, and certain things are going to absolutely take off and flourish. So that's why I'm so excited about Celestia, is that in some sense, it's solving this infrastructure problem is the first step. And I think once these modular blockchains are mature, we're going to open a whole, Cambrian explosion of different use cases and applications. However, I don't know exactly what they're going to be.
Yeah, that actually answered my question. It is hard to know, but the infrastructure part is key to solve in these early stages. So are you guys going to the Cosmoverse? Are you attending to the Cosmoverse in Colombia next month?
We will be there, yes. Yeah, we're one of the sponsors. So if people are going to be there, we'd love to see them. And I love Colombia. I've been to Medellin twice before, and
nice.
Beautiful city. So I'm very excited to be there and meet everyone and meet the Latin American community.
That's very nice.
Are you going to be there?
Yes, I'm actually traveling. I'm flying on the 4th of September, so like in 2 weeks, because we're also planning the WASM hack. So we're planning the hackathon. There's going to be 48 hours of hackathon from the 1st of October, 10 a.m. till the 3rd of October, 10 a.m. So it'll be great if you can just, if you're going to stay a little bit longer after the Cosmoverse, it'll be great to just have you there to see the devs, see the teams, maybe just for a little bit. That's great. Yeah, I'm excited to see you guys there.
Yeah, I'll have to practice my Spanish as well.
Okay, yeah, well, we speak Spanish here, so anytime. Okay, so yeah, I feel like this was a great call, and I feel like you guys are full of knowledge, and I feel like you guys see the big picture, and you're aiming to solve these infrastructure problems that we currently have. So I'm very excited about Celestia. Thank you, Nick, for being in the channel. This was great.
I really, really appreciate it, Alex. And I'm so grateful for people to listen in, and hopefully you guys learned something. If anything was not clear, we have a whole Learn Modular section on our website, and we have a bunch of other interviews. I encourage people to follow us on Twitter or even, reach out on our Discord or Telegram. We love kind of like interacting with people, and we're so early, and we really need to scale the knowledge, right? And get people to understand this new revolution of modular blockchains. And so that's one of our primary jobs, is to share that knowledge with the rest of the world. So really look forward to meeting more of you online and in person at Cosmoverse and at other conferences. It's really a pleasure, Alex. Thank you so much.
Yeah, thank you. Thank you for your time.